Hello students, welcome to my YouTube channel Civil Edu Next. Myself Maitri Dave, Assistant Professor at LJ Institute of Engineering and Technology. Today we are going to discuss about building construction. In second lecture, let's discuss different topics about building construction. But before that, let's discuss what we have learned in previous lecture. So basically, we have thrown light on the topics like classification of building and building components in detail. So now, in today's lecture, we are going to describe basically the types of load acting on building, and our second topic is types of foundations, right? So without wasting much time, let's get started. So what are the different loads that acting on any building? So basically, dead load, live load, wind load, earthquake load, and load due to rain and snow are the main, or we can say a primary load that acting on any building. So before constructing any kind of building, we should understand and also calculate all kind of load acting on building so that we can provide safety factors regarding to that particular load. So here on screen, you can see different load acting with respect to different directions on a building, right? So now let's discuss all in detail. So first is the dead load. So what is a dead load, right? So it is a permanent, immovable and untransferable load. It means it is something which is fixed. So for example, I can say that the weight of material is something which is permanent, right? So here self-weight of structure is considered to be as a dead load. So I can say that the all component of any building is considered to be as a dead load, like walls, roofs, floors, partitions, ceilings and water tanks, that all are going to be considered as dead load. So the question is how to calculate a dead load. So we can calculate it by multiplying its volume by unit weight of any material, because different material has different unit weight, right? So here a table is given on screen where different materials like PCC, RCC, steel, bricks masonry, stone masonry, timber, water and granite has different unit weight. So for calculation, it is very important, right? So this is all about dead load. Now let's move to the second one, which is live load. So what is live load? So basically, a load which is movable, temporary and variable is considered to be as live load. So here I can say that the people who are living or working with that particular building is considered to be as live load. Even the furniture is also considered to be as live load because it is movable, and sometimes we can add and remove that furniture as per the requirement. So I can say that weight of inhabitants, residents and furniture or any stored materials are the live load, right? So here different buildings that we already learned in classification of building based on purpose, like residential, industrial, right? So all building required different kind of furniture as well as number of people varies accordingly. So here in this table, a description of different types of building like residential building, offices, bank, assembly halls, warehouses and stairs are given with respect to their minimum live load in kilonewton per meter square for your better understanding of calculation. So this is all about live load. Now let's move to the third load, which is wind load. So here wind load comes in picture when we talk about the tall buildings, right? So which building we should consider to be tall building? When the height of building is greater than twice of its width than it should be considered as tall buildings. So this is the concept of a tall building. Now here you can see how a wind pressure acts on any building. So generally it is expressed in terms of basic wind pressure, which is an equivalent static pressure in the direction of wind. And if I have to calculate it, then I have to do calculation that P is equal to kV square, where as I said, P is the wind pressure in kilonewton per meter square and K is the coefficient depending upon wind velocity, size and shape of the structure. As per the building code, it is generally decided as 0.0006, right? While V is the wind velocity in kilometer per hour. So this is the calculation for wind load. Now let's move to the next topic, which is earthquake load. So what is an earthquake first? So basically, let's assume we are moving in a bus. So whenever the bus is going and a sudden brake is applied to it, then our body is try to resist ourselves at that particular point. The same thing acts with the building. When building is standing and it is actually moving with the earth, but in the earth, the tectonic movements, or we can say the movement in between tectonic plates take place at the time the horizontal directional, or we can say an impact force, sudden impact force is acting on the legs of the building. So building is trying to resist themselves, right? So we can say earthquake load is something which acts horizontally, right? So the tall buildings affect the more. So here, how to calculate it? So for that, we have to calculate M into alpha, where I can say M is equal to W by G into alpha. Now what is this? So here M is the mass of the building, W is the total weight of the building, G is the gravitational acceleration, and alpha is the acceleration due to earthquake, which is generally 0.2 to 0.1 G, right? So this is the calculation of earthquake load. Now moving further, the next is the loads due to rain and snow. So these both loads acts on roof, right? The uppermost area of any building. So depending on the shape of the roofs and its capacity to retain the snow and rain load, we should calculate its total load. So if I talk about generally snow load. So generally load of a snow is equal to 2.5 kilogram per meter square per centimeter at the depth of flow. If the roofs having inclination greater than 50 degree, right? It means the slope is provided greater than 50 degree, then snow load may be neglected as the snow removes by itself due to inclination. So that is the concept for snow load. Now what about rain? So generally roofs whose position, shape and drainage system where accumulation of rain is possible, rain load is considered. So this is all about loads due to rain and snow. So now in this topic, we have discussed all the loads in detail like dead load, live load, wind load, earthquake load and load due to rain and snow. I hope everyone is getting my point. Now moving to the next topic, which is types of foundation. So the first question is, what is a foundation? Foundation is provided to transfer the load of total building to the soil. So it is very important or the first step while we are constructing any kind of buildings, right? So here it is divided into two types. First is the shallow foundation and second is the deep foundation. So here on screen you can see that below ground level whatever we are constructing is known as foundation, and whatever by D and the width that is denoted by P. So if depth is less than or equal to B, it is known as the shallow foundation, and if it is greater than B, it is known as deep foundation. Is it clear everyone? Okay, now let's discuss it detail. So what is shallow foundation can be? So it can be further classified into number of types, in which first is the spread footing. So what is a spread footing is? So spread footing is spreading the load of total building on a large volume to the soil, right? Now, generally, it can be again classified as single footing or bed footing, step footing and slope footing. So what is this? So here you can see on screen that single footing is something when a single column has a simple uniform concrete base below that, right? While in step footing, we are providing step in between. For what we are providing this kind of steps? Because we want to transfer the load gradually to that particular base. It is very useful when impact load is high and we want to transfer it very gradually. Same case with the slope footing. So here again a slope in trapezoidal shape is provided to simply transfer the loads. Even on screen you can see how on field this kind of construction can be done. So this is all about single footing, step footing and slope footing. Please keep in mind these all for the columns. And now you understand that if I am talking about a column, it means I am talking about a frame structure, right? Okay. Now, let's discuss the next topic, which is simple wall footing and step wall footing. Here on screen, you can see the examples of simple wall footing and step wall footing. Here again, the concept is same, but we are talking about the wall footings. It means on a wall, if I want to transfer the load from that wall, it means wall is acting as a load bearing component, then a concrete base is provided throughout below the wall. And if I am adding steps to it, then it is known as the step wall footing as shown in this figure. So this is all about load bearing structures, right? So now you are getting the concepts and connections between load bearing structure, frame structure and regarding to their foundations, right? Now you have various options required for different types of load acting on building and how to transfer it by providing different types of foundation, right? Now, let's discuss the next, which is grillage foundation. Now, this is something which is provided below the structure, right? Now, here the two examples are there for grillage foundation as shown in this figure. Here we can also go for the steel as well as the timber grillage foundation for transferring the load. So this is all about the spread footing where we have talked about the column, wall and grillage foundation with their various different classifications also. Now let's go to the back to get a better idea what we are going to discuss in shallow foundation next. That is about strap footing. Now what is strap footing? So here on screen you can see that two columns are there, right? But now when I am trying to transfer the load, if I connect that two columns base with a simple beam, then it is making things very easy in transferring the load, or we can say providing more safety to our foundation. So here a beam which is we are connecting is known as the strap beam, and the total footing who is connecting this kind of two columns is known as the strap footing. So this is the application on field is very useful in this kind of conditions. Now next is the combined footing. Here you can see that two columns are nearby, right? And if I am providing a column footing, it means a simple column footing, then the base can be overlapped to each other. At that time, we should go for the combined footing so that the overall strength of that particular area or to that column is increased and is economical, right? So this is the concept used when two columns are very nearer and this kind of load is also acting on that particular building. Now, here on screen you can see two different shapes. One is the simple rectangular and second one is the trapezoidal. Now, when we should use the rectangular type of combined footing. So here when two columns having same size, we should go for the rectangular, and if the size of column is different, then we should go for the trapezoidal footing. So this is all about combined footing. Now next is the raft or mat foundation. So whenever I want to give a proper firm support to my building, then at that time I am going to provide one foolproof foundation of my building's original shape to below that. It means now I'm not talking about the column or wall. I am talking about the building itself. So whenever I am putting foundation with respect to my building shape or size or throughout the building, I am providing this kind of RCC materials for acting as my foundation. It is called as raft or mat foundation. It is very good in terms of strength. So maximum load when we are talking about multi-story building is going to transfer to the soil. At that time, this kind of foundation is a very good option, right? So now this is all about shallow foundation. Now last we will discuss about the deep foundation. It means I can also know deep foundation as pile foundation. The question is, what is a pile foundation? So here on screen you can see that deep foundation or pile foundation is something when we have to go deeper in the soil. It means I have to deal with the number of strata having different densities, right? So here on screen you can see lower density, medium density and higher density. And the structure is known as the pile, that up to which depth I have to go. But as I said, if I transfer load directly to that foundation or the piles, then it is not practical solution. For that, I have to provide some cap that is known as the pile cap. So which transfer the load of total load of structure gradually to the pile and then to the soil. So this is the concept of pile foundation. Now let's discuss how we can construct this kind of piles. For that, first thing is we have to install the casing. It means the outer frame. For that, first we have to drill that particular area, or we can say to excavate that earthwork, right? After excavation, we should reinforce or install our RCC mixture so that it can be stabilized over there. After some time, it can be set at that position. Then after, we just extract the casing. It means now our piles are set in the soil and according to our requirement of transformation of load, it is set into the soil. So this is the procedure for pile foundation construction. Now let's discuss which are the different types of pile foundation are. So basically it is divided into 4 types. First is end bearing, second is friction, third is combined end bearing and friction, and last is the compaction pile. Here on screen you can see the examples, right? So in the first one, where the end bearing pile, you can see a hard strata is there. It means our pile should be touched to the hard strata so that it can transfer load directly to the hard strata, as the total load of building is quite high over here, so that it is most important that our lower strata should be hard strata. Second type is the friction piles. So here on screen you can see the arrows going in upward direction. It means a friction is acting to the piles in the soil. So this is the indication that friction is resisting piles to set at their position. So that is known as the friction pile. Third one is the combination of these two. It means we are not rely only friction, but we also go up to the hard strata. So we can gain advantages of both the types. That is known as the combined end bearing and friction pile. Next and last is the compaction pile. Now here on screen you can see the compaction pile. So for that, let's assume that we have a plot, right? And in that plot, the soil type is of sand. And now if I am going to tell you that just construct a high-rise building or multi-story building in that particular plot, then your question is how we can construct that much heavy construction on that sand only, because as we all know that sand does not have bearing capacity, a good bearing capacity I say. For that, what we can do, we can compact that area by adding other materials like cement, sand, timber, steel. Now, how it can be increase the load bearing capacity of that area? It means a limited area having some material like sand, and if I am adding sand or any material into it, then with some spacing, constant spacing, it means it is compacting the material, soil particles. So this is the concept of compaction pile. So this is all about the pile foundation. Now you have better idea that what are the types of foundation, what is shallow foundation, deep foundation, and what are the other classification into that. So this is all about types of foundation. So in today's lecture, we have learned different types of load acting on building, which is very important before constructing any kind of building, right? And after calculation of load, you can design foundation according to requirement to transfer that load of the structure to the soil, right? So this is all about for today's lecture. See you soon in the next lecture. Thank you for watching. Don't forget to like, share and subscribe my YouTube channel Civil LJIET Next.